Today we're going to discuss finding real roots of polynomial equations. Some polynomial equations can be solved by factoring. Here's an example. X to the fourth minus 13x squared equals negative 36. Before we attempt to factor this polynomial equation, let's first move all the terms to one side of the equation. So we will add 36 to both sides, giving us x to the fourth minus 13x squared plus 36 equals 0. Now let's attempt to factor the trinomial. Notice that the three terms do not share any common factors other than 1, so we cannot pull out a common factor. Because it is a trinomial, let's draw two sets of parentheses and see if we can factor this trinomial into the product of two binomials. First of all, look at x to the fourth. What two factors of x to the fourth can we use that will allow us to multiply out to get a middle term with an x squared? We know that x squared times x squared is x to the fourth. So let's use those two factors. Next, we will look at the constant term, 36. What pair of factors of 36 would add to give us a negative 13? One and 36 clearly would not work, nor would 2 and 18, or 3 and 12. But 4 and 9, when added, results in 13. So if we make both 4 and 9 negative, we know that negative 4 plus negative 9 is a negative 13, and negative 4 times negative 9 is a positive 36. So it appears that we have factored this trinomial into two binomials. Notice that both binomials are a difference of two perfect squares. So we can factor these binomials further. X squared minus 4 factors into x plus 2 times x minus 2. And x squared minus 9 factors into x plus 3 times x minus 3. Now we have factored the original polynomial into 4 linear factors. We can now set each factor equal to 0 and solve for x. X plus 2 equals 0 results in a root x equals negative 2. X minus 2 equals 0 results in a root x equals 2. X plus 3 equals 0 results in a root x equals negative 3. And x minus 3 equals 0 results in a root x equals 3. So this polynomial equation has 4 roots: negative 2, positive 2, negative 3, and positive 3. Notice that each factor occurs only once, so each root is a singular root, and we say that each root has a multiplicity of 1. If you wanted to sketch the graph of this polynomial as a function, we know that the zeros are where the graph crosses the x-axis. So at negative 2, and at negative 3, we have zeros. And at positive 2 and positive 3, we have zeros. Because the leading coefficient is positive, we know that the shape of this graph would be open upward, which would make it appear to look like a W. So the graph would take on a shape similar to what I've just drawn.